So thanks for joining. Good morning, everybody. Just to give you a bit of an introduction to what's going to go on today. So my name is Matt Hirschfield, Senior Consultant at Optimize Engineering. This is part 3 of our Control Alt Engineering series of webinars. We're going to be looking at verification and validation, V&V for victory today. During the session, we will be taking a look at those processes, and basically the plan was to have a little bit of a demonstration at the end of the tools. Unfortunately, due to technical reasons, with our demonstration zone, that's not going to happen today, so you'll get a bit of time back at the end, hopefully. So the planned session will be a little bit shorter. But yeah, we'll get things underway anyway. We've still got a few people coming in, I think, but we'll get started. Okay, right. So we'll start off with just a little bit about me. What I will also do is I'm just going to switch my camera off so that so that you don't get to look at my ugly face whilst I'm doing this. So just give me a second. There we go. Okay. So a little bit about me. My career has been centered around my hometown of Hull. I've always been interested in technology, mechanical, electrical, IT based, anything that I can possibly get my hands on and break. I'm quite happy to faff around with, basically. To give you a brief summary of the sort of types of technology I've worked around. Basically, there is an animation that should be coming on now, but it's not, as is usually the case with these. There we go. Look, so yeah, started off my career really in 1998 as a fruit machine engineer, working on gambling machines. I then moved into as a final test technician for a CO2 marking laser. That's the one under 2001 there. That was a job where I was on my tools, basically using doing final calibration of the lasers, basically optical systems, the electrical systems, etc. 2013, I jumped jobs and took a job in a local company who made airport baggage handling systems. So hopefully you can see that image there. That is a tilt tray sorter delivering bags onto a conveyor system, and then basically these things would take your bags from the check-ins and then take them up to the aeroplanes, and then vice versa when you're coming back off the aeroplane as well. So around about 2021 during COVID, basically, the airport industry projects around the airports sort of died away. There was very little project work going on, and the opportunity arose to become part of the IBM ecosystem and get involved with the IBM tools. I will say that as part of my work within the airport baggage handling system at Daifuku there, I was involved in the administration of the IBM ELM tools. Prior to that, we got involved with Doors Next as well. So that's Doors Classic, and that's where I sort of started became sort of involved with the IBM tools on the coal face there. Okay. So a brief sort of agenda for what we're going to cover today. We're going to take a look at verification and validation, as I say, start off with a bit of an overview, and then we're going to stroll through the sort of key principles of both V&V practices. We're going to look at the process inputs and activities. We're going to summarize the benefits of it, and hopefully we'll have time at the end to discuss any of the topics covered. What I will say is that this session is aimed to be sort of thought-provoking, and we're not being prescriptive. We know that every organization is different. You've all got a different approach. But what I've tried to do with the content on this sort of session is sort of base it around what the principles of the ISO 15288. So I mean, obviously, if there's something that jumps out at you think, well, I don't do my process, I don't do my V&V in that way, or you've got some more questions to ask maybe at the end, we can have a discussion about that towards the end of the session. So as I say, we had planned to do a bit of a demonstration, but that's not taking place now, so we'll have a bit longer to discuss, to sort of cover those questions as well. Okay. The only other thing to say as well is that the slides and the presentation recording will be available on our website after the event. Okay. Let's get started then. So, what is V&V? We're going to start with the textbook answers. Regulations such as ISO 15288 and ISO 9001. For those that don't know, these are industry standards that document the processes to be applied in systems, lifecycle, and quality management systems. And to avoid sending you to sleep on slide 4, I took the liberty of checking out each standard to find out how it describes the purpose of verification and validation. Okay, you'll be pleased to know that both standards describe verification and validation as distinct processes. We talk about V and V. It sounds like it's the same part of the same thing, but it's not. It's two distinct processes. Okay. The other thing to mention is that the descriptions between the two standards was pretty close to matching. Okay, the sentiment is pretty much the same. Okay, across those standards. As I mentioned earlier on, for the benefits of this webinar, I'm going to focus specifically on ISO 15288. Now, 15288, it states that the purpose of verification is to provide objective evidence that a system or subsystem fulfills its specified requirements and characteristics. Okay. The purpose of validation is to provide objective evidence that the system, when in use, fulfills its business objectives and stakeholder requirements, achieving its intended use in its intended operational environment. Now, to me, that gives you a bit of a clue about, or may give you a bit of a misnomer or a red hanger about the way in which verification and validation take place in the project lifecycle. What I will say is that these are governance processes. So basically, these processes should be adopted design stage all the way through the life cycle of the product, basically. So whenever you are introducing change or dealing with issues within the system design or the product itself, any changes that go through in terms of the way it's structured or the way it is intended to be operated should go through a V&V process in terms of, as part of those quality processes. So let's take a deeper look at some of the reasons why you would want to go to the trouble of including these processes in your project delivery lifecycle, starting with verification. Okay. Why do we verify? The first P in our 3P mentality here at Optimize is people. Okay. It's a fact that every documented engineering project failure can be attributed to people in some way. Okay. Truth be told, if anything is ever going to make a mockery of all your hard work as a systems engineer, it's going to be people. Let's start with our favourite group of people, the customers. Contrary to popular opinions, the customer isn't always right. Sometimes customers want things that are impossible to deliver. Then there are our peers, people who work alongside us and are aiming for the same destination, corporate success, but taking a slightly different route to get there. Then there are our users. Okay, so these are the people at the end of the chain who get to use our system once it's been designed and delivered. Users are the people that always manage to find a way to make your elegantly designed system behave in ways that it was never designed to. Another reason why we verify is project governance. We verify our designs to ensure that the stakeholder needs and business mission objectives have been correctly assessed, traced to relevant system requirements, and most importantly, are achievable before moving to the realization stage. When implementing changes to a system, either as part of a fix or a redesign, we must ensure that the proposed changes are verified against the original stakeholder needs and mission objectives and system design. The key benefit for performing verification is to capture and correct any misconceptions before the product realization begins. It's much easier and cost-effective to fix an issue whilst it is still on paper. Verification also gives us the opportunity to share this information with project stakeholders, building confidence in the project delivery time and resulting in a happy customer. That means we're all on the sales team now. When do we verify? Mentioned it earlier on, we verify throughout the project and product life cycle. Ideally, verification reviews should take place before handing over any piece of design or product information internally, and certainly always before releasing design information to the project stakeholders and the project decision makers for approval. Okay. On the screen, we can see some of the internal verification activities I've picked out there. So things like requirement reviews, design risk assessments, project risk assessments, all of these activities that we probably do informally or we're doing as part of project, project delivery. it's about assigning that to verification. Basically, that's what we're doing. We're verifying what we're doing to make sure that it's correct before we move on to the next stage. It's worth mentioning that engineering teams that do perform these activities informally without sort of capturing the effort or documenting the evidence are always going to struggle to demonstrate the value of the effort required to deliver high quality products, because these are part, verification is part of that process of delivering a high quality product. How do we verify? By implementing P number 2, process, specifically the verification process. Having a defined verification process in place in an organisation helps teams to understand how to develop the verification strategy and plan the verification activities. This could be part of a systems engineering management plan or even just a standalone verification process. Mention that word strategy. We need a strategy. The verification strategy should define how and when an organisation expects verification to take place. It should document the key performance indicators, the KPIs that measure not just the quality of the product, but also part of the process itself. So it's a feedback loop as well. So we can, once we start the activity of capturing that formally, we can put metrics in place to see how long it's taking to deliver that verification, how long, the effect it's having on the output of our products as well. Okay, so one of the key aspects is listing the verification objectives. So what's the purpose of the verification activity that you're doing? Is it an internal review? Is it a milestone review? These are all things that will determine the activities that are taken part in that are actioned as part of that verification activity. The other thing there's a list of things that our verification strategy does, but providing the verification criteria as well. So explaining to the delivery team, what's good, what's bad, and what the bits in between. Okay. It should also state the process outputs. So what are we expected to see at the end of the verification process? Is it a raft of documentation? Is it sign off from the customer or the client? Is it sign off from an internal team to say, yeah, we're happy to take this part of the design or deliver this change into the software part of it, and that's what we're doing. We're basically collaborating with the stakeholders on the project. Okay. The strategy should also describe how to manage deviations and exceptions. So that's when you're going through that verification process, and it doesn't have to be just a stop at the end. It's also things like your requirements management process of ensuring your requirements are smart. The specific, measurable, achievable, relevant, time bound, all that good stuff. Okay, so anywhere where we've got a deviation from that, we need to sort of explain as part of the strategy for verification how that's going to be handled. So is it through concessions? Is it through project change control? Is it different mechanisms will apply depending on the sort of nature of the project and the complexity of the project as well. In essence, the verification strategy gives us the framework to develop our verification test plan. The verification process should be tailored to suit the complexity of the project and the agreed strategy. However, the following key inputs should be included. Verification criteria. We can't do any verification until we actually know how, what's good, what's bad. How are we, how do we determine whether this thing has been verified correctly or not? Initial stakeholder requirements. It's key. If you're at the point where you're going to verify the design of a product, what are you verifying it against? It's always going to be against the stakeholder requirements. It's also going to be against those, those sort of higher level system requirements that are in place. Okay. Also the business mission objectives. So, we've got the requirements to customer, the what they want, what they need in part of the delivered system. You've also got the strategic level decisions around how your organization wants to deliver those needs and deliver those stakeholder requirements in terms of the quality process, etc., and how that's going to be delivered. Okay. Things to check. Do we have a design concept for the system? Have we defined its scope? Do we know and understand the system boundaries? Life cycle concepts. Do we have an understanding of how the system will evolve from the concept stage through to retirement stage and all the bits in between? And those concept stages are about identifying, how it's going to be, how the early parts of it could be how raw materials are purchased, how raw materials are checked, individual checks and tests to make sure that everything is in place. As we've got a framework to understand what we're checking against, basically. Interface definitions. How will the system interact in its intended environment? That's key when you get to the validation stages later on in the slides. But basically, it's about understanding what the intention is around how that system's going to work when it's released and when it's in full operation. Okay. When we talk about interface definitions as well, it's not just about the project, the product, sorry, it's also about the project. So it's about how the project's going to be managed. Who are the stakeholders? What are the mechanisms for reporting progress, reporting updates, raising those deviations? So we're looking at concessions. How do we apply to concessions? How do we go back to the customer and say, you've got this requirement in there, it's difficult to deliver. This is the knock-on effect of delivering that. It's going to affect budget. It's going to affect other parts of the design, essentially. Okay, so we need to have those interface definitions in there, so we know how we're going to do that. System requirements. That's key. This is what it's all about. We're talking about verification and validation. The foundation to those are good system requirements. Do we have a fully traceable set of system requirements? Functional, non-functional, contractual, and regulatory, that are traced back to specific stakeholder needs, business objectives, higher level system requirements. So not just the stakeholder requirements, but also the subcomponents or sub elements within the system design, basically. Okay. And again, all of this will depend on the complexity. All of these requirements and these sort of things that we're looking for will be determined as part of that strategy and the way that we're intending to deliver the project, and the complexity of the project as well, and product. Nearly missed that bit. So verification activities. Verification activities. We're gonna start performing some, start looking at verification methods, basically. How are we going to verify something? So there are different methods and techniques we can employ to verify our products and our designs or our changes, basically. Okay. Inspection and review. At the verification stage, this normally involves systematic examination of design documentation to ensure that, one, the stakeholder needs, VMOs or the business mission objectives, system requirements have been assessed and reviewed and satisfied. Our traceability matrices, looking at the, which bits of where we've got coverage, where we haven't got coverage, can we move forward without 100% coverage, etc. Mentioned this before earlier on. So all the proposed system requirements, can they be traced back to an accepted stakeholder need? And are those system requirements smart? Are they specific, measurable, achievable, relevant, and time-bound? If they're not, during the verification stage, that's the time to raise that with the customer. That's the time to raise that with the project teams. How to resolve that? Okay. Next one's key for me. All non-compliant and unaccepted stakeholder requirements, are they mitigated through project quality process? What I mean by that is, for those exceptions and those gaps in the compliance, if you like, of the design that you've produced, is there a way of mitigating that through risk? Is there a way of going back to the customer and discussing that with them? Is there a way of making changes to the requirements that are the stakeholder requirements in order to get that accepted through at the verification stage? I mean, these things can come out through, trade studies, further analysis of the needs, about the about the capabilities required. So, just basically, the key to both processes is having a framework to be able to communicate and manage manage and ensure that we are meeting the requirements that the stakeholders needs, basically. And when we say stakeholders, that's not just the customer, it's also the strategic stakeholders within the organization you're working for. Any inconsistencies, missing elements or deviations from the requirements should be resolved through the project quality process in order to avoid gaps or conflicts between the requirements and required capabilities. Okay. So that's inspection and review. There are other methods of checking, of doing verification as well, such as MBSE analysis and modeling techniques. So these can be used to as a method of graphically representing the expected and assumed use cases of the system. Behavioral scenarios as well. Checking that these are logically correct. Do any of the expected scenarios or system requirements cause a conflict with other parts of the system when it's running? Okay. So typical examples of MBSE analysis are, use case, data flow, and state models, behavioral diagrams. These sort of, if you like, derived or elaborated sort of system elements or sort of system design artifacts, as we call, as I'm going to use the phrase now. Let me retweak that. Derived or elaborated sort of requirements and use cases need to be traced back to a system requirement or a stakeholder need. There's got to be some traceability there. And the key to having a good verification and validation process in place is being able to ensure that we are validating right the way back from our verification test and our validation test, right the way back to a stakeholder need. What's the driver behind it? Okay. Demonstration through simulation. So again, simulation can be, it can be part of the MBSE approach as well. So we could be doing a sort of a digital twin or a soft version of the system and assessing and analyzing and testing how the different modules. And I always think, because of my sort of past experience, I always sort of focus more on sort of the physical system design, but also the software design as well. So when you're introducing a new piece of code or capability, ensuring that piece of code or capability that you're implementing doesn't detract from an existing part of the system or the software. Okay. So demonstration. So that was demonstration through simulation and prototyping. So yeah, I mean, it could, as well as soft prototyping, it could be a hard prototype as well. So you could be doing sort of unit testing at a prototype level as well, just to make sure, mechanical, electrical, control interfaces are working as intended on a test rig potentially. Okay. So testing and evaluation, we sort of moved into that one next. So we mentioned about system sort of testing and verification there. So one of the key benefits of doing some simulated system testing at the verification stage is that you can test that end-to-end sort of system behavior and align it with those functional requirements before the realization process begins. So again, we're left shifting. We are getting to the point where we are doing all of that testing before we've physically created something, before we've incurred the cost of buying materials potentially as well at production levels. Okay. I mean, obviously there are situations where, you've got different levels of delivery as well. You could be delivering a one-off bespoke piece of infrastructure or a one-off piece of machine, basically, or you could be doing volume production of components or machines, essentially. So, the key to verification, as I keep mentioning, is testing that with the design that we've got or the changes that we're going to be implementing at the verification stage are going to work as we intend them to do. Okay, before it becomes a physical system and it ends up costing us lots of money to fix. Okay. Some of those products that I've already mentioned, so they may need to go for formal verification. So for high assurance and safety critical systems, you may need to do sort of mathematical proofs of for other formal methods that guarantee that the system behavior conforms to the required specifications. Okay. All of these aspects that I've mentioned there, that they're dependent on what's being delivered. Not every project is the same. Not every product is the same. Okay. The methods that we use to deliver verification, it's got to be selected and to suit the complexity of the project and what's being delivered. It's also got to fit with the budget constraints. That it might be a strategic decision where, there's a level of testing that takes place before release or before handing over to the client, and you move on from that. Basically, that's got to be agreed as part of the contractual part of the project. Execution and recording of the verification activities. So we're carrying out our chosen activities, our chosen verification methods systematically. We go through, we check, we make sure everything's everything's being verified. For each requirement that we document, for each verification step that we take, we document the outcomes as pass, fail, or not applicable. Okay. Any discrepancies or failures must be logged for corrective action. So again, anything that doesn't pass that verification needs to be reported. It needs to be analysed. It needs to be understood why. And then we need to determine what the correct course of action is to resolve that issue. After successful completion of the verification project, the key output is a verified system design along with the supporting documentation. So this becomes really critical in tightly regulated industries, where we have to maintain a trace and an auditable trail of design decisions, who decided on what's happened at which test, when. That supporting documentation provides that. It gives us an opportunity to demonstrate that we are following our quality processes correctly. It gives us an opportunity to define, this is the system before it's gone to the realization stage that we are handing over, or this is what we are accepting in terms of changes before we are making a change to a live system, perhaps. This information, as I say, acts as evidence to support the proposed system and document how the system has been checked and assured. Once that's done, we can move on to the product realization stage, start acquiring the resources needed to manufacture and deliver the system. So next comes validation. And I'm just checking on the time, and I think we're doing okay. Okay. Remind me, why do we validate? To provide objective evidence that the system, when in use, and I'm emphasizing the term when in use there, fulfills its business or mission objectives and stakeholder requirements, achieving its intended use in its intended operational environment. So that's 15.288 basically. That's what the purpose of validation is. The other reason why we validate is also people again. Yeah, the soft squidgy things again that sort of get in the way of beautifully designed machines being released and passed on to the customer. We validate our delivered system to ensure that the design team's vision has been realised. When I say the design team's vision, that could also be that could also be due down to not just a new product. It could also be a change. It could also be an update, a fix. So basically, ensuring that any fixes that we deliver are don't interrupt don't change the original sort of stakeholder needs and business objectives. Okay. We validate to ensure that the procurement team has purchased the right materials. The manufacturing team have constructed the system correctly. Everything fits in the right place. All the connection leads are in the right at the right length, etc., etc. We also validate to ensure that the testing team have delivered the system and met the original stakeholder requirements. We'll come into this in a little bit more in the next couple of slides, but when we're talking about validation, it's decomposed again. It's looking at, it can be done at different levels, basically. Validation is the final opportunity to ensure that the project has successfully satisfied the needs of the stakeholder and the business mission objectives. When do we validate? It's a really good question. If we think about that purpose that the that 15288 states, validation appears to be all about, end product delivery, or, after the product has been realized in some way or shape or form. Okay. In essence, as part of the project process, we should start that validation effort as early as possible. There's nothing to stop the validation team being part of, the sort of tender process, so they can share insight and share concerns about any of the system design the stakeholders' needs. And again, these processes are about organizations breaking down silos, introducing the right people to the team at the right time, rather than, that siloed sort of way of delivering, engineering team, sales team chucking things over the fence, engineering team picking it up, having to deliver something impossible. I know I've been there myself. But key things to start the process off as early as possible. What do we need in place? We need some sort of operational concept in place. So we need to understand how the system is going to be, intended to be operated in its sort of final state. We need to be able to see those stakeholder requirements. So once those stakeholder requirements are there, yeah, we can get the validation team in, start looking at them, start understanding what's got to be delivered, start raising those issues as early as possible in the project lifecycle, because it's going to be much easier to communicate that to the customer and end up with a successfully delivered system at the end. Okay. As we mentioned, actual validation of the system elements or the wider system can only begin once the system is in its intended operational state and environment. As with verification, validation starts with the process. The validation process should outline the expected validation activities so that we can formulate a validation strategy and tailor that to the project objectives and complexity. Validation test plans should also be drafted to suit the project and system complexity, ensuring that the validation effort is aligned to the agreed validation strategy. Validation test plans should, as a minimum, sort of capture the information such as identify the stakeholders, who's going to be delivering the test, who's going to be reviewing the test effort, is it going to be the user, is it going to be end user testing, is it going to be sort of strategic level testing? It'll all depend on the actual validation effort that we're going through and the sort of the type of validation testing we're doing. Okay, that comes on to the next thing. So scoping out the validation effort, that validation effort really wants to be decomposed. We need to be checking out the system is as early as possible as it's realized, basically. So we want to be doing things like component testing. We want to be doing like sort of unit testing as well. So we're testing individual circuit boards, individual, or in the software world, testing individual pieces of code and capability to ensure that when it goes into the end application, or be that physical or software, basically a physical machine or software, we know the individual components work, and it's any issues that come up after that, we're looking at how it's been integrated with the system. We're looking at interfaces. We're looking at how the sort of the environment that subcomponent is working in, to resolve that issue. Okay. We establish a list of validation constraints. So what are the constraints around validation? I would have thought most people would say it's the time element. By the time that we get to validate the system, we've run out of time, but it should have been delivered 3 months ago, 6 months ago, 6 weeks ago. Resourcing, that if you are trying to organize the customer's sort of user team, it's making sure those resources are available when the testing can take place. You may be making a change in a live system, which requires that those changes to be made offline, during non-production time. So it's making sure that we've got everything in place, all the right people, all the right resources, and that we can carry out that validation effort, in line with the requirements, basically, in line with the process. We also need to define what the accepted validation methods are. So, how are we going to test this? Is it going to be through demonstration? Is it going to be through sort of stress testing? Are we going to chuck 3,000 bags through a baggage handling system and make sure they all end up in the right place or not? Or is it just going to be, is it going to be, let's test individual baggage lines basically and make sure that the bags are routing in the right direction before we do that. All of these things, will determine how we're going to test those things. Prioritization and schedule of the validation effort, that the process should identify when those tests are going to be, when the testing is going to take place, and that needs to be in line with the agreed strategy, in line with the agreement with the customer. If we're delivering, if we're not delivering a sort of large piece of infrastructure material and it's something in-house, a piece of machinery, have we got all the kit available to do the testing? Is the test bed available for us? That's the kind of thing that we need to sort of ensure that we capture as part of that prioritization and scheduling of the validation effort. As the project process progresses, and the proposed system changes or the proposed system changes start to take shape, further details should be captured, such as determine the acceptance levels for the design or the validation coverage. So what I mean by that is that, when we're running these tests, are we running one test and, an individual test on an individual subsystem? Does it pass? Does it, what's the method for actually, that passing a test basically? Next is identifying those enabling systems or those supporting services and products for the validation process. So this comes back to sort of a list, also feeds back into sort of constraints. So, when we're testing something in an integrated way, have we got, can we test the unit that we're putting in or the system that we're putting in alongside in its intended environment, alongside the systems that it's going to be working alongside, interfacing with and communicating with. Key point, risks. When we are testing a new system or a new piece of code or a new piece of design machine capability, what are the associated risks with that? Have we captured all of those? Have we done a risk assessment on that? Have we made sure that the people that are testing the system aren't at risk of any what's the word? At risk of injury or having an adverse effect on other parts of the system. Okay. Validation objectives. So we mentioned it earlier. Test purpose. Which feature and capability are we validating? The test method will depend. The test method will depend on the requirement type being tested. Is it functional? Is it a performance? Is it availability? Is it security? So there'll be different ways of testing those requirements. Okay. Validation scope. Oh, sorry. Shifted up a little bit there. Give you a bit of spoiler alert there. Sorry. Validation scope. So test boundaries, test specification that should be aligned with our requirements. Test expectations, expected results. Part of that test effort or that test case should be to describe what the intended outcome is. It shouldn't just be a case of does it. It should be a case of what happens when we do this. This is what should happen when we follow these steps. Is that correct or not? And that feeds back into our acceptance as well. So there may be more than one step in a test case, depending on whether an individual step fails. Do our acceptance levels mean that can be, that the test can be passed or not? Is there a weighting behind a specific part of the test step or a specific test case which would stop that validation test being successful and passed passed as validated? Again, scheduling. Last point on this slide is, when's the testing going to start and end for each system level and each system element? Okay. Here we can see the IPO diagram for the validation process. This has been borrowed from the Systems Engineering Handbook. And it gives us a sort of an idea of the kind of things that we need to be looking at from a process perspective for validation. So again, we've got some inputs, we've got some activities, we've got outputs in there. Okay, so we've got some of the key ones in there. Life cycle, life cycle concepts. We mentioned that earlier. How does the system, what is the concept about how the system's going to operate when it's delivered and when it's in its final sort of operational state? Stakeholder needs, key. If we're validating, we need to make sure that we're validating against those stakeholder needs. RVTM, so that's a requirement verification traceability matrix. So that's looking at how the requirements have been traced and verified, and showing that traceability through that early stage of the design concept. So is everything satisfied? Have we got full coverage on that? Are there any gaps on that? We don't want to be testing something that's not actually, we might not want to be testing something that's not actually tied back to one of the original stakeholder requirements. It could be an elaborated one, but that should also be tied back to those stakeholder requirements in some way through traceability. Validation criteria. A lot of the content that we've gone on here, we've been through in terms of the inputs for the process. Okay, but the key the activities that we've got as part of the validation process, preparing for validation. So that's where we're checking the inputs, basically, make sure we've got everything in place, make sure our test cases and our test plans and our test scripts are suitably verified against the design requirements. Performing the tests, we run through the tests, we capture the successes, we capture the failure rates, we raise defects, we raise issues, we raise bugs, basically. Those are the kind of things that we start to build data up within our engineering processes, and we need to be able to manage that data. We need to be able to say, right, okay, this is our test effort. This is what we plan to do in terms of testing. We're hitting issues with trying to deliver a capability or a set of requirements, basically. What can we do to resolve that? Do we need to change the test? Do we need to change the capability, the functionality in some way? Do we need to change the customer's expectations about how this specific requirement is, needs to be delivered? Okay. Once we've completed those activities, you can see there's a great big list of outputs that we've got there. The key one is at the end of the validation process, we need a validated system. We need to have a documented system, a validated system that's been documented, so that we can prove to our clients and we can prove to the stakeholders of the project that this project has been delivered successfully. All of those documents that we've discussed, the validation strategy, the system requirements, the constraints that have been in place, imposed on the project, they all go towards documenting the end system. They capture decision making, they capture who's made what decision when, and whether that was a strategic one, whether it was a technical one, whether it was something that needed, unexpected, if you like. So once we've got those outputs there, I mean, there's a big long list of outputs there, but again, it's going to be tailored to the complexity of the product, basically, and the project that you are delivering. One of the other aspects of validation I'm going to go through now is when we're doing our requirements management steps and we're doing that verification, we decompose those stakeholder needs down into levels of requirements. So we look at we start off with those stakeholder requirements, we decompose those down into business objectives. Those then become high level system requirements, then gets decomposed further down the design chains to ensure that the detail that we are capturing and making sure that all the detail that we're capturing is it is in line with what the stakeholder needs originally were. Okay. Validation activities should be decomposed and validated against those decomposed system designs. So what I will say, this graphic was just one that I've sort of put together myself. I know, from working with lots of different organizations, that everyone's got their own take on this about how they're going to link, how they're going to do validation testing, whether they're going to be testing multiple test cases against one, what one capability is validated against several several different test cases, or an individual capability might be tested against a single one. It will depend on the complexity of the products, your validation strategy, etc. But this just gives an example of a possibility there. The possibilities are endless, basically. Well, what we are trying to show here is that we've got, our testing, our validation should be aligned to the decomposition of the requirements, or on the other side of the V, basically. We've got component testing in there. We've got sort of system elements or subsystem testing. Then we're going to an integrated sort of system as well. So once those components are being put together, and basically as we're going up the side of the V there, I'll get my little laser pen on here, just so I can do this. So, as we're going up this side of the V doing the validation, okay, the end goal is this delivered validated system, okay? What we're doing by decomposing these down is we're aiding the validation process because, testing these components work, everything works great, we put it into a system, or we've got an issue, okay? We know the components work, it's something to do with the system. And that ripples up the chain, if you like. So, you've done your validation testing against system elements. You put it into the integrated system. It starts talking to enabling systems around the deployment, and we start getting issues, right? Once we've passed that point, we know that all of this works correctly. Well, we expect it to work correctly. It might be that when we start doing this level of validation testing, that we do need to review these and say, well, actually, this subsystem doesn't work in its intended environment. We need to go back through the change process. We need to understand what's causing that within the design. It doesn't just stop there, though. You can hand over a product, and I always sort of focus myself, or I always sort of think about sort of large scale sort of machines, or sort of building level sort of machinery, if you like. It could be that part of the validation approach is qualification testing. So that happens over a period of time after handover. So we are measuring how the system's performing. It's an environment. There might be cause to look at some of the system design. There might be cause of some unexpected environment, or the environment changes in some way, and that needs to be reassessed. Again, this is something that we handle as part of the product life cycle and goes through the change process. Okay, so yeah, we've successfully delivered the item. It's working as it should do in its intended environment until a point when it doesn't. Be that user training, or be that an unexpected sort of component failure, if you like. So there are other levels of testing as well at this point. Things like ORA, or operational readiness, and operational readiness acceptance testing, basically. So have we got all of the documentation in place to support the product? Have we got all the spare parts that we need to support the product? Have the users been trained up in how to use the system, etc. There may also be third-party independent testing required. It could be that you need to go for CE approval, you need to go EMC testing, things like that. Anything where you have to get a third party to look at your product, that happens after that process is, after our sort of internal processes have taken place and after the system's been delivered. Okay? But again, it's another level of validation which may come into play. Yeah, I'm nearly there. Sorry, my mouse has just decided to stop working. Okay. So in summary, I've just looked at the clock and realized I've waffled on for quite some time now. Verification and validation, it's not just a means to an end. Both processes provide the feedback mechanism to capture how a project has been delivered and received, allowing organizations to monitor and improve those processes and ensure high quality delivery. V&V activities are inherent across the field of engineering, whether the effort is captured formally or organically through just sound common sense. We've asked on a number of different occasions through this session, why do we conduct V&V? Why do we do verification? Why do we do validation? There have been many documented examples of how the smallest details and gaps in requirements, misconceptions around the stakeholders' needs, can lead to catastrophic system failures. poor interface design, a failed O-ring, user error through simple lack of understanding, or all of these aspects, with on successfully delivered projects, which in their intended environment, maybe not straight away, maybe 1 year, maybe 2 years, maybe a month down the line, start to cause problems, and there's part of the design that didn't take that into account. Okay. The aim of verification and validation is to ensure that the system has been designed to meet the business mission objectives and that the subsystems interact correctly as a complete system. V&V activities also need to take into account system requirements that aren't explicitly requested. Those derived requirements. We need to make sure that we are checking those out, making sure that, operating the system under a certain environmental condition doesn't cause another problem. System behavior that isn't intended but possible. A user instigating a command or initiating a command using controls. It does it. If it's not part of the design, how do we handle that in the software? How do we handle that through alarms and feedback to the customer to stop anything happening disastrously? Changes in the operational environment. Moving items. We'll think about the automotive industry. You've got products that they're designed to work in a range of temperatures. What happens if you take that vehicle outside of those temperatures? Does the control system stop working? Do the brakes stop working? Does it lock people inside on a hot day? That kind of thing. The other things that we need to take account of are sudden or prolonged component failure. So what happens if something goes wrong in the system? How is that reported? How is that managed? And how is that monitored? And the final sort of step is simple user error. How do we sort of, we need to take account of people not doing the right thing or misusing the product. Okay, how do we handle that? So the final P in our 3P sort of statement there is products. And the next part of this, the next couple of slides, and we're nearly there, don't worry. We're going to look at sort of some products that will be able to help those V&V activities. Okay. I will be honest, we were going to do a bit of a demonstration today, but due to some technical reasons and probably all the waffling I've had to do on this session, we didn't think we were not able to do that demonstration at all. But what we will say is that if anybody wants to have a look at how the IBM tools, which I'm going to come to next, I'm going to click the slide across now. Any of these tools that we've got shown on the screen at the moment, if you want to have a look at how these tools can support, improve, and sort of streamline and make your validation and verification efforts more easier to handle, give us a call and we'll certainly take you through the tools. Okay, so for those of you that don't know the IBM tools, so IBM Engineering Lifecycle Management Suite, this is what we're kind of specialists in terms of optimized engineering. It comprises of 3 core applications that integrate seamlessly across the system's engineering lifecycle. ELM includes doors next for requirements management and capture, engineering test management for your validation effort, and the planning and execution of validation tests, and the engineering workflow management tool for tracking the work effort, change control, configuration management as well, defect tracking and all that good stuff. For advanced sort of verification activities such as model-based systems engineering, IBM's Rhapsody tools offer rich MBSE capabilities supporting both SysML v1 and SysML v2. They can also be deployed and used for simulation activities, so creating those sort of the prototypes, the panel diagrams, that kind of thing, and doing that electronically, digital twinning basically. Okay. They can also be used to generate code automatically in test cases as well. Out of the box, these applications connect seamlessly over using OSLC. The OSLC standard defines the data structure of the artifacts in each of the engineering domains. So it tells you what a requirement's going to look like. It tells you what a test case is going to look like, or a test plan. It also tells you what an architectural element will look like, such as an event in a state diagram, etc., a use case diagram, an actor, that kind of thing. So basically, OSLC describes what those artifacts do in each of those things, in each of those domains. Okay, well, I can say thank you very much. We've actually come to the end of the slide deck now. I'm surprised we've actually got through to an hour on that one, but we've got a couple of minutes now. Do we? I notice we've got some questions in the Q&A.
Yeah, Matt, just to add to that, I've allowed all the mics for attendees if there are any.
Yeah,
You know,
yeah, sure. Yeah, if anyone's got anything they'd like to pull me up on, or anything else, I'll try and answer any questions. So Tim, I noticed you raised something. Please, can you repeat the two standards that you referenced at the start of the process? Absolutely, yeah. So ISO 15288. So this is the systems engineering standard basically, and ISO 9001. That is specifically focusing on quality management systems. For your benefit, Tim, if you still, Tim is still here, I can see him. I can see him in the middle of my screen actually. The slide deck will be available as well after once we finish the session. We'll be putting it on the website. So if you want to hop on and drop onto it, you can do. Okay. Was there any other questions or any other sort of points that anybody wants to raise? Okay, well, look, thank you very much. I'll take silence as a positive thing that you're either falling asleep at your desk listening to me, or most of what I've covered was acceptable to you guys. So thank you once again for your time. I hope it's been of value to you. Oh,
sorry,
Rob's got a question. He's got his hand up. Hi,
I
Rob.
just thought of one. Within the IBM toolset environment,
Yeah.
within, say, Doors Classic originally, that was, orientated primarily around requirements. You could generate modules that would, be your VCRM to do your verification work.
Yeah.
In Doors Next Gen, is it typically, is it linked and, coupled closely to the requirements like it would have been in Classic, or are there specific add-on tools, add-on software, and you kind of buy it in modules? How is it kind of structured in Next Gen?
So in Next Gen, it's a good question. So you're right, in Doors, in the world of Doors Classic, basically, people would add in those additional attributes or within the module, etc., and capture extra different data. You do have the option of doing exactly the same within Doors Next. You can add those attributes in, you can create those modules, and you can create those matrices basically. One of the key things here is that as part of ELM, you've got test management, and you've got the reporting, and you've got the change and configuration management applications basically. So straight out of the box, if you can buy each of those sort of core applications as an individual application, or you can buy them all as a complete suite. If you buy them all as a complete suite, you get access to the reporting domains, you get access to the test management, and you get access to the change and configuration.
So there is a test management. There is a test management.
Yeah, there is a test management application
tool
in there. Yeah.
Yeah, application tool. Yeah, okay. So you could live without it, or you could purchase it specifically.
Yes, absolutely. So one of the other things on here as well is, as I mentioned, OSLC. So some organizations, they do have, they may already have a test tool in place. So if that tool speaks the OSLC language, you could replace the quality management, the test management tool, with one that you've already got in house. So you can start to link your requirements up to your test cases and your test plans, etc. So yeah, I mean, ELM is a fantastic tool. Really good I really wanted to give a bit of a demonstration about the things I've chatted through today, but unfortunately, it was technical gremlins crept up and bit me. So yeah, does that answer your question, Rob?
Yeah, I think that's fine for now. I'm just sort of I was wondering how the tool was structured and sort of comparison with other market softwares that are available and how they do it in, complete end to end. And this is going to sound a bit cynical and skeptical, but Doors Next Gen in my eye is sort of a halfway house between the tools of yesteryear with IBM sort of Doors Classic, and then you've got full-blown sledgehammer PLM systems which do everything, and Next Gen seems to kind of slot in between that level. It's still got reporting, it's still got workflows. But yeah, I've not used Doors Next Gen, but I was just trying to size it up in terms of where it fits in that hierarchy.
Well, if you wanted to have a bit of a session and have a look at the tools in a bit more detail, I'm quite happy to set a call up, Rob, and we can an hour and a half. We can do a bit of an exploration of Doors Next. I can show you the benefits of it. I mean, one of the big key differentials. Well, before we go into Doors Next, one of the key sort of unique selling points for these applications is you haven't got point-to-point integrations. So, if you buy ELM, your requirements talk to your tests and your requirements talk to your defects. Basically, it's all on the one tool. You haven't not going out to external organizations or external application vendors to get interfaces and adapters to create that traceability across the life cycle. As is the case with the architectural side of things as well. I don't know if you're aware. Rhapsody, which is the architectural tool from IBM, it comes in two flavors now. There's a true web-based version, which is Rhapsody SE, specifically looking at a SysML v2. That's accessed through a browser. It's not a thick client anymore. Whereas the Rhapsody 10, as we're calling it, that is a thick client, and that's the one that does all that great stuff like the code generation, test generation, automatic test generation as well. And so these tools will allow you to sort of generate that traceability right the way from concept level right the way through to the validation testing and the handover of the tools. And one of the other things about the reporting domains as well is that you can you've got built-in reporting capability, which allows you to create the dashboards, which I'm quite happy to show you through some of those things. But you've also got some formal reporting options as well, so that you can extract, you can do all your work within the tools, and then you can set up templates which allow you to sort of output those reports, capturing all that traceability, capturing the audit history. So when you come to hand that information over to the client to get paid, you've got all your design documentation there for you. It builds up with that technical file basically. So
Okay, right. So it's not just reporting in the sense that it's the classic of Doors Classic is spitting out metrics, requirement counts, maturity counts, compliance counts.
Yeah.
Yeah.
I mean, you can do all of that, but then those reporting domains, it's web-based basically. So when you hit the project areas, you get a nice dashboard. You get you get the you get to see what's happening. You get to see the graphical representations of what your traceability and your coverage, etc., and your compliance levels as well. And the verification to make sure that you've done all those bits to start off with.
I assume a lot more automated in next gen though.
Yes, yeah, absolutely.
Yeah.
Well, it's automated. It's got a lovely interface for creating those reports. I've always been bald basically. So certainly for longer than I've been using the IBM tool. So yeah, it's fairly intuitive to get up to grips and get those dashboards set up. And in fact, actually, as part of ELM, you can actually. It comes with predetermined dashboard reports as well, so you can sort of start pretty quickly, get off the mat pretty quickly.
And final question, sorry, and then I will let you go, is how interoperable is the requirements set with Rhapsody? As in, so from an MBSE, a lot of the project work I do for myself and for clients is kind of MBSE centric, relatively manual, relatively siloed one side and the other.
Okay.
And what I'm never really, what I've never really seen on a project successfully, even with PLM tools that like promise it, is the true interoperability. You create a functional object, textual object within, say, in your textual space, Doors or Next Gen, and you could link it to a functional object within your modeling space, and you have push-pull of the data flow back and forth. Does Next Gen do that? Can you link
so
interface objects and functional objects and architectural objects with each other in both spaces?
Yes, it does. Is the succinct answer on that? What I will say is that there, as all good tool vendors do, there is an added capability that you need to deploy in order to be able to link those Rhapsody MBSE elements up to your Doors Next requirements. Basically, it's called Rhapsody Model Manager or Model Manager. Yes.
Okay.
I'm just falling off my tongue there. Yeah, it's Model Manager basically, Rhapsody Model Manager, and what that is, it's actually an extension. What it does is it actually extends the capability of the change and configuration management tool, so it allows you then to create your design, create your models in Rhapsody at one side of it. You can then connect from Rhapsody through Model Manager into change and configuration management. So what that does is it uploads the elements and the bits of data that are in your model into the change and configuration management tool, and from there you can connect your requirements to them. Now, what you normally do with this is you would have what we call configuration management enabled as well. So any changes that you make to your requirements, you would then release those down to sort of push those out into your models. So when you come into Rhapsody, you open your model up and it says basically, oh, there's been some changes. There's been some I wanted to say conflicts. That's not the right word. There's been some updates basically in the requirements domain. Do you want to accept those changes into your model? And it gives you the opportunity then to look at the changes and decide whether you want to change your model, accept those changes, or whether you want to take a variant off from that and take a branch off, import those changes in, and then take that model off on a different journey.
That's interesting because again, yeah, that's useful because of course, just because you make a change in your textual information doesn't necessarily mean you want to push it, and you do need that control. Because if everything just changed willy-nilly, there's no control there, is it? And would it work vice versa if you're making changes in the model?
Yes,
someone's changed the name of this function, and you can see that impact.
Yes, absolutely.
If you've made the link,
it works both ways basically. So any changes in the model as well, basically you can elect to accept the changes through the baselining and through the configuration management tool. That's part of the Doors Next application. Oh, which actually we've got global configuration as well. So it's not just affecting your requirements management; it's also affecting things like your test management as well. So your test and your defects, test and your test cases and test artifacts basically. So if you change the functionality of a behavioral diagram potentially, or a use case diagram, it's going to have a knock-on effect on your test cases. It's going to affect how you're going to test that functionality. So being able to say, right, okay, yeah, we're going to accept that in, but we're going to have to do some test effort. It allows you to do that within the tool, basically. Is the shorter answer.
Okay, yeah, no, that sounds interesting. You the best person in discussions potential.
So you went a bit Norman Collier there, Rob. You broke up a little bit. I don't know if it was my internet connection or if there's a fly on the.
No, I think it's the mic. The laptop mic. I think it's a little temperamental. Right. Sorry, what I was saying was I'm in with a client at the moment about potentially a software direction change. Are you the best person if I were to give?
Absolutely, yeah,
give them your name and set stuff up.
Yeah, no, absolutely. Drop me a line, and we can jump on a call and we can do some explorations on the tools and the capabilities, and show you some of how this works in the real world. Well, I say the real world in terms of our real world, basically. So, but yeah, no, I can do that. Drop me a line, and I'm quite happy to set a call up, and we can have some further discussions, man.
Okay, I've got a sort of I'm on your mailing list through a standing relationship with Mark. So I can see him in, but I don't know if he's in the prime contact for software sales these days or not. But,
well, if you send anything through to the CET address, we're all on there. If you send anything through to me, I will obviously include the team in it anyway. And if you want to jump on a call, as I say, I'll invite the technical team along, and we can.
Yeah, I'll have a discussion with them and see what's what, if you see what I mean.
Yeah, no, absolutely. Okay. Yeah, no, okay, excellent. Right. Well, look, thanks for your time. I hope I haven't. Hope it was acceptable to you guys, and look forward to speaking to you both in the future, hopefully.
That's great. Thanks a lot, Matt. Bye.
All right. Cheers, Rob. Cheers, Tim. You okay there, Tim?